Welcome to this explainer. Today, we're putting on our detective hats to investigate a microscopic killer that literally leaves gardens looking like a charred crime scene. I'm super excited to guide you through this because we're looking at some absolutely fascinating plant pathology. We're going to treat this like a botanical true crime investigation, uncovering the clues, the victims, and, well, the seriously unusual getaway tactics of one very specific pathogen. All right, let's just dive right in.
So what could possibly make a tree look completely scorched, even when there is absolutely no fire in sight? Today, we're going to learn how to identify a devastating plant disease that makes branches look just like that. I mean, imagine walking into your beautiful backyard orchard and seeing what looks like the aftermath of a blowtorch. But, there hasn't been a spark anywhere. It's a totally baffling and honestly heartbreaking sight for any gardener. So how does a tree look burned without fire? Well, the answer lies with a tiny, invisible attacker.
Section 1. Meet the microscopic culprit.
Say hello to Erwinia amylovora. This is a relentless, ancient bacterium that's been plaguing specific plants for generations. And what's really wild here is that fire blight isn't some new, mutated garden pest. No, it's actually one of the oldest known bacterial diseases of plants. This pathogen has had centuries to perfect its attack, which is exactly why it's so highly effective, and honestly, why we really need to pay attention to how it works.
Section 2. Victims of the blight.
So if you've got members of the rosacea family in your yard, they are prime targets for this bacterial attack. We're talking about your beloved apple and cherry trees, delicate roses, juicy peaches, ornamental pears, and photinia shrubs. The absolutely crucial point here is that if your garden relies heavily on these specific plants, you are essentially setting up an all-you-can-eat buffet for fire blight. Knowing this host range, that is for sure your very first line of defense. Section 3. Scene of the crime. Let's step onto the scene and examine the physical evidence left behind.
Notice how the young twigs and branches die from the terminal end, right? They droop over in this very specific wilted way. The bacteria doesn't just attack the trunk. It goes right for the tender new growth at the very tips of the plant, causing this really rapid collapse of the tissue.
Now, experts call this distinct bending symptom the shepherd's crook, and it's your first major visual clue. If you're out there inspecting your apple or pear trees and you see the very ends of the branches curled over, kind of like a walking stick or a shepherd's staff, red flags should absolutely be going up. This structural collapse is a hallmark signature of the pathogen.
Moving on to the next piece of evidence, you can see the infected twigs become dark, dry, and distinctly water-soaked. This gives them that terrifying burned appearance without any actual fire. And yeah, this is exactly where the disease gets its name. The bacterial infection moves through the vascular tissues, effectively destroying the plant's plumbing. The resulting dead tissue turns a dark charcoal black or deep brown, making it look literally like someone just held a lighter to your favorite tree.
You'll also see cracks develop and branch cankers form on the wood. These aggressively continue to grow until they completely encircle and kill the infected branch. These cankers are essentially necrotic dead zones right on the bark. Once a canker wraps all the way around a branch, a process known as girdling, everything above that canker is entirely cut off from nutrients and water, and it just dies. It is a ruthless, highly efficient strangulation of the plant.
Section 4. The bizarre bacterial ooze. This is where our forensic investigation gets wonderfully weird.
Look closely at this infected apple. You're going to see a strange, physical exudate leaking right out of the fruit itself. It almost looks like the fruit is sweating thick, milky teardrops. This isn't sap or dew, guys. It's a direct result of the intense biological battle happening just beneath the skin of the plant.
By definition, this substance is bacterial ooze, and it is absolutely packed with the microscopic culprit we discussed earlier. Actually, every single droplet of this ooze contains millions upon millions of Erwinia amylovora bacteria just waiting to spread to a new host. It is highly infectious and incredibly dangerous to the rest of your garden.
Getting up close here, you can see this ooze has a frothy, wet-wood nature to it. But honestly, its most bizarre characteristic isn't how it looks, it's how it smells. You'd think it might smell like rotting vegetation, right? But nature always has a trick up its sleeve.
Incredibly, the ooze actually ferments to smell alcoholic, drawing in insects like hornets and literally intoxicating them on the spot. I mean, you can't make this stuff up. The bacteria creates a sugary, fermenting cocktail that acts as an irresistible bait for insects. The hornets land, feed on the alcoholic ooze, get a little tipsy, and in the process they get completely covered in the highly infectious bacteria.
Section 5.
how the infection spreads. So, we know the bacteria is concentrated in that strange ooze, but how does it jump from tree to tree? Let's trace the final steps of this crime.
The big takeaway here is that fire blight travels through the garden via extreme weather, intoxicated bugs, or even your very own unwashed gardening shears. When the wind blows hard during a rainstorm, it can whip that ooze into a fine mist, spreading it to nearby blossoms. Those drunk hornets and other insects fly away, land on a healthy tree, and deliver the bacteria directly to a new host. And perhaps most tragically, we gardeners often spread it ourselves. If you prune an infected shepherd's crook branch and then immediately use those same tools on a healthy rosebush without sanitizing them, you become the accomplice to the crime, introducing the bacteria right into a fresh wound.
So by understanding the host plants, recognizing the shepherd's crook, spotting that telltale burned appearance, and knowing the dangers of that strange alcoholic ooze, you are now totally equipped to stop fire blight in its tracks. But it leaves you wondering, if a microscopic organism from centuries ago has evolved to use intoxicated hornets as its getaway drivers, what other invisible, highly orchestrated botanical battles are raging in our backyards right now while we aren't looking? Keep observing out there, and thank you so much for joining me on this explainer.